Hello guys and welcome back. So today and this week we are going to focus on another type of molecule called a polymer. So let me go ahead and write that on the screen for you. Hope you guys are doing well, by the way. Coming down the home stretch of all of this kind of stuff, which is crazy. Especially you 8th graders, you guys, I was telling you guys in the Zoom, those guys that were there, you're closer to high schoolers at this point than you are to middle school, starting middle school, which I don't know if that's really sunk in for you guys yet. But anyways, polymers. So looking at this word, if you break it up, that first part, poly, means many. So a polygon has many sides to it, right? It has many sides and angles. Okay, so before I get too much further in defining what a polymer is, I think it's helpful if I go back and I kind of just refresh us on what we're talking about, because some of the feedback I'm getting is, oh, I have to remember all this stuff going back and back and back. And it's like, yeah, you do. Science is something that kind of builds on itself. But I want to make that as easy as possible because, again, I know it's complicated, especially over this remote learning. But think about what we first started way back in January. We started talking about atoms. And we did our periodic table. Well, it would help if I turn this guy on. Please wait patiently. Ha, green light means it's on. Ha. All right, so you have your atom, okay? So your atom is going to be made up of 3 parts. So I'm going to start on this side. It's going from small to large, okay? So the atom, if we go back up into the smaller parts of our atom, we have 3 parts, and those were protons, electrons, and neutrons, right? So each atom is going to be made up of those 3 things. However, we got a lot more complicated when we went through, when we learned about bonding and all of that kind of stuff. And atoms don't just stay by themselves. If they did, then we would only see however many elements there are worth of things. And they would kind of all stay these like isolated little things. But we know that atoms are interacting with each other. They're making bonds and they're forming things which are called molecules. So molecules are going to be your next step up, okay? So molecules are going to be when atoms are bonded together. So you have more than one atom, 1 plus atom, okay? So you have at least 2 atoms that are bonded together in either, remember, there were 2 types of ways that we can have this happen. We can have it in covalence, covalent bonds, like they're sharing the electrons, or, and I didn't mean to put the S there, that's my bad, covalent, or you could have ionic compounds. Now, a specific type of molecule that we're going to kind of focus in on a little bit is called a compound. A compound is when you have different types of elements. So see, we're not really changing the definitions here. It just all matters what kind of things you have bonded together. So every compound is a molecule, but not every molecule is a compound. So let me type that out for you guys so you don't forget. So every molecule, or every compound, my bad, is a molecule. Not every molecule is a compound. So for example, if I have something like this, if I have O2, that means I have 2 oxygen atoms that are bonded together. And that is a molecule. So we're here, but we're not a compound. A compound would be CO2, because now we have carbon atoms and we have oxygen atoms that are being bonded together to make that compound. So now let's get into polymers, which are all around you. Okay, so polymers. How did they get started and what are they exactly? And to get thinking about how you see these in your everyday life, I want you to think about looking in your house, looking at places that you go to, how much of what you interact with is actually made out of plastic. Plastics are, for the most part, polymers. So the way that polymers were made, they're a type of molecule that's made of a lot of repeating parts. So I'll get you the technical definition in a second after my story here. So reasons why we needed polymers. Think about this. So these are billiard balls, and they are made of ivory, and or they used to be. They're not anymore in most cases. But think about this. So every time somebody wanted to play billiards, they would need a full set of this, which is made of pure ivory, which would have killed 1 to 2 elephants for every set. So that means every pub or bar or whatever in the 19th century that had this would have consumed an elephant, and that's just crazy. So this guy, Hyatt, actually produced one of the first what we would call plastics or polymers that was artificial, and we call that celluloid. Make sure I spell it right. Cool, I spelled it right. All right, so celluloid. And now we can replace the ivory, which is obviously really expensive and kills elephants, with something that is a little bit easier to work with. Other example here would be something called Bakelite, which basically replaced shellac. So shellac is made out of actually basically this insect, really, really specific type of insect that lives on this tree. It produces kind of like a resin as kind of a residual waste product. And so they would use that, and it's kind of like a varnish that you put whenever you're done with a woodworking project. So that's obviously going to be really time consuming, really not energy efficient, because you have to harvest it from this really, really specific scenario we find in nature. So instead, Bakelite kind of has the same sort of effect and looks really similar. That was made around the early 20th century. So like 1906-ish, 1905, somewhere around there. And then from there, everything took off because we could see, oh, these polymers, we can kind of bend and mold them however we like. And it has to do with the chemistry of what polymers actually are. All right, so right here are your definitions right here. So monomer and polymer are two things that you're definitely going to need to know for this next unit. So a monomer is a molecule that can be bonded to other identical molecules to form a polymer. So it's basically kind of like this. The way I always explain this to students is that monomers are kind of like beads in a necklace. When you string them together, you get a more complex molecule. The polymer is the entire necklace together. So for example, I'll make a simple polymer if I have my supplies at hand. Look at me, just a mess here. Oh, here we go. So here, this is a paperclip. Obviously, this would be my monomer, okay? So notice if I take an exact copy of this and I kind of do something like this, if I can get this to work. Well, this is what happens when you're really tired on a Sunday. Here we go. Cool. So I've bonded together the two monomers to make a polymer. Now this is a really, really small polymer because there's only 2 paper clips. But notice the cool thing about polymers is you could keep adding more and more paper clips to it, which is what makes them so flexible. It's what allows them chemically to be able to just keep going and going and going, and what makes them valuable. So if you keep bonding and bonding and bonding more paper clips, you can get bunches of different structures. So what does this look like chemically? So I'll give you an example here of polyethylene. So polyethylene looks like this. You have one carbon bonded to a bunch of hydrogens, and it looks like this. Now keep in mind, if you remember from your Lewis dot structures, carbon has 4 places to make bonds. And so what happens is you just keep going and going and going with this same thing over and over and over again. And so you can add on and build the directions and create these really long molecules. It's kind of like adding a bunch of paper clips to each other, right? So polyethylene is a really, really popular plastic. It's what you can find in a lot of like plastic bottles, like shampoo bottles and things like that. Even bags, like garbage, maybe some garbage bags, some grocery bags, all sorts of things are made of polyethylene. It's a super, super popular one. So the monomer here would actually just be ethylene. And I do want to add here that not all polymers are going to be synthetic, meaning made by people. Some polymers are actually found in nature, things like wood, wool, and even some of the complex molecules we use for life are considered polymers. So they're not always going to be what we would call synthetic. I'll write that on here for you, meaning they're man-made. Even though the most obvious one that we think of is plastic, and plastic is obviously synthetic, weird to think about that plastic has been around for not that long. Not until the late 19th century did we have plastic. Before then, we were using all sorts of other things. So there you have it, guys. That at the end of the day is what a polymer is, and they're made up of monomers. So we'll get more in detail about specific types of polymers that I would like you to know, besides some of the ones I mentioned here. So feel free to go back, take notes, do whatever you need to make sure that you get everything out of this lesson. Also, do not forget to be doing the classroom discussions every week. Those do add up, and some of you guys are forgetting to do those. So don't forget to do your classroom discussions and also build on 2 peer responses. You will not get full points if you do not respond to your peers. At the end of the day, that is pretty much it. We will do some a little bit more interesting stuff, hopefully, with how you can make a polymer and what that looks like on the next time. All right, bye guys.